Just to introduce ourselves, I'm Saurabh Gupta. I work as the data platforms team lead from a sales engineering perspective in UK and Ireland. I've been with the company for the last 18 years, close to 18 years, and I have been in data management space for roughly 25 years. And I have my colleague Kinshuk here. Kinshuk, if you could introduce yourself, please.
Hi, I'm Kinshuk Rakshit. I'm a sales engineer with UKI Data Platform. Been with InterSystems for about 5 years, and I'm mostly interested in cloud services, scalability, automation, that kind of thing.
Okay, thank you, Kinshuk. So just to give you a brief snapshot of how we will spend the next 1 hour, close to an hour, I would say. First, we'll look at when we talk about financial institutions are getting smart about data and what we mean by that. And we'll introduce a new architectural concept called data fabric. And we'll see also what we mean by smart data fabric. Then for that particular architectural concept, what is our implementation of that, which is what we call as InterSystems TotalView for financial services. So we'll talk about the solution, its capabilities. We'll look at some of the use cases which we are helping our customers and which we believe we can help other customers in this space by using these capabilities. We'll do a brief demo and we'll keep last 5 to 10 minutes typically for Q&A that anybody might have. But please keep the questions rolling in the chat window. Even if you're not able to answer them today, we'll definitely get in touch with you and answer those queries. So if you look at it, the challenge that we are trying to solve, or most of the financial firms are trying to solve, is how can they become data-driven? And essentially, to become data-driven, they need to have end-to-end single version of truth of their data. And having said that, it's not a new problem that you might have heard about. It has been a problem for so many years, but it has been trying, and organizations have been trying to solve it using multiple approaches. People still use manual methods. People still use spreadsheets. Most of the organizations in some shape or form have invested into data warehousing. And I would say in the last 10 years, people would have also, some of them would have also gone down the route of data lakes, where essentially the idea was to, can we create a repository of both structured and unstructured information, which we can use for analytics and drive decision-making within the organization. Whereas traditionally, the data warehouses were pretty much targeted towards structured data. But one of the challenges which still remains the same is basically, having said that, this problem has always been there, but still it's a complex problem to solve. And the reason for that is that more often you would find very complex IT landscapes within large organizations where they're using best of breed applications for a particular thing. They might be using their own front office, middle office, back office solutions, separate data warehouses, and still it remains a challenge in terms of creating a single version of truth, which reliably they can use for decision making. And the other thing which has happened in the last few years, the consumers who want to access this data has also become very varied. Traditionally, if you look at it, people built their warehouses and actually connected a BI and a reporting tool to it, and they did their analytics in that space. But if you look at it in the last few years, with so much innovation happening on the machine learning side and AI, and now with generative AI, the reality is that the same data that you want to create as your single version of truth also needs to be made available for some of these innovative use cases where people want to use machine learning or AI capabilities to drive decision making. And again, at this stage, it's more like enabling them to make decisions as opposed to taking decisions on their behalf. And I think so for very foreseeable future, that's how we see it. The other part is that once you have created the single version of truth, whether you have created a single view of customer across all the relationships that you might have with the customer, or you might have a single view of an organization for all your internal users, then essentially people want to surface that information in some of the composite applications, which could be either a mobile app or an app which people can access, which traditionally was not possible because essentially it was difficult to get that data as a single version of truth. So if I were to say the problem that we're trying to talk about here is not new, it still remains a challenge. And different organizations are at different, let's say, are in different space in terms of solving this problem. But more importantly, the kind of consumers they now need to support has become much more varied. So essentially, if you look at it, it requires what is called, if I were to call it as a modern data management approach, which Gartner gives a term to it as a data fabric, which essentially means that every organization, this is what the organization is trying to deliver: a unified, integrated, intelligent, end-to-end data platform to solve all their use cases. And if you look at it on the slide, these are the capabilities that they need as part of that data fabric implementation, or I would say an architectural approach, where essentially you need your modern data platforms to support all these capabilities to essentially become a data-driven organization. And what we are finding, or what we are trying to work, is taking it to the next level, where it's not just about creating a single version of truth for different consumers, but it's also about enabling analytics on top of that, enabling AI on top of that, enabling machine learning on top of that, and of late enabling some of the generative AI use cases on top of that. So essentially, this idea of a smart data fabric is almost like a connective tissue which sits within your organization, which basically creates an enterprise view of your data, a consistent view along with the metadata. And the way it works is that, and how it differs from the traditional way of doing data management was, the traditional way of data management was always based on ETL processes. You extract, transform, and load into a data warehouse, and you put a BI tool on top of it. Whereas the whole idea of data fabric is it needs to work in a hybrid mode. And when I say hybrid mode, I mean connect and collect. So if you already have a data warehouse which was built for analytic workloads, then you should be able to just connect that and surface that by normalizing and cleaning it. Or if you are trying to connect to an operational system where obviously those operational systems were not built for that purpose, then you still might need to extract the data and normalize it and harmonize it and clean it. So essentially, if you look at it, the whole idea of a data fabric approach is to provide this both connect and collect paradigms around creating the single version of truth of the data. And the capabilities that you need around data management in this space, which are shown in this slide, like you need connectivity, you need, let's say, different types of data that you can consume. So you need multimodal capabilities. You could get data in the form of, let's say, CSV files. You could connect to databases or application adapters, or you could get data in a semi-structured form like JSON, or data could be unstructured like PDF documents and things like that. And then you need to be able to basically bring all the data in, normalize it, transform it, reconcile it more often. So if you have customer data coming from two different systems, how do I make sure I reconcile my customer data so that when I'm doing analytics on top of it, all my aggregations and all things can work on it? And the other new concept is basically is that if you look at it, typically in the old way of data warehousing was always still a very technical representation of your data. And how do you create that business representation of data which your business users can access, and you abstract all the complexity around how the data was moved and how the data was normalized, clean. And that's where the concept of semantic layer starts coming in. So essentially, if you look at it, there are a lot of capabilities that you need as part of building this data fabric across your organization to enable what I would call as your modern data platform approach, or your new data platforms within your organization, which essentially allows you to cater to multiple consumers and takes you in the direction of self-service BI or a data-driven organization. Now, obviously, you could go about natively in a cloud today, look at different services, and start working with those services and integrating those services to create a data fabric, and then start worrying about the problems. So essentially, if you look at it, organizations could go in one approach where they say, well, we have enough IT professionals, we can go into the cloud for each of these capabilities, we can subscribe to different services in the cloud and actually start working in creating our own data fabric and essentially start delivering some outcomes. But that's a very long drawn approach, risk driven, because it will take 6 months to 1 year to even create a fabric around your organization with all these capabilities, because you have a lot many different services, lot many moving parts, how they interact with each other, and you're moving towards complexity. And our approach in this space is basically, how can we provide a unified service, which is a data fabric implementation for all these capabilities, and it allows you to actually start delivering the outcomes on day one. So when we set out to implement this data fabric approach, obviously people who know us, we have been into the data management space for the last 45 years, starting from Cache as a database and of late Iris as the newer version of that database. And people who know our database management capabilities would be versed with it. But essentially our approach has always been speed to value and simplicity and performance at scale. And these are the hallmarks of our technology. And behind the scenes, what we have is our data platform, which is called Iris, which essentially, if I were to put all the capabilities that you need for a data fabric implementation or a smart data fabric implementation, are pretty much around data management to handle multiple kinds of data and also to scale it horizontally and vertically. You need integration capabilities to be able to connect to different systems, add workflows to the data ingestion pipeline so that if something goes wrong, actions can be taken. Then you have process orchestration, which allows you to automate some of your manual processes. And then you have all sets of analytics capabilities, be it real time, which is the embedded analytics capability of our platform, or be it the semantic layer capabilities. How do you create a business representation of data? All these are available as part of our Iris as a data platform. But the key thing is, again, if we were to only provide a data platform, then again, even though all the capabilities are there, but to be able to deliver a data fabric, you would again have to build lot many components using Iris as a data platform. And that's what we have done now is basically, if I were to say, is our proposition or our data fabric implementation, which we call as InterSystems TotalView for financial services, where essentially what we have done is using all the underlying capabilities of Iris as a data platform, we have built what we call as a data fabric implementation, which gives you all the capabilities to connect to different sources, provides you control mechanisms, which is essentially like when you are ingesting data from multiple systems, you need quality controls, you need data validations, you need data transformations, you need data reconciliations, and how we could make it easy for you to build these data pipelines without having to worry about complexity of any programming language or data management complexity or all those things. How do we make it simple for you to start delivering outcomes which you need for being a data-driven organization, and then to be able to create the single view of data and store those data models within the platform, and then start using those data models for analytics or for machine learning, or you're trying to access the data through REST APIs to surface that data into applications. All those capabilities, we have almost weaved the data fabric for you using Iris as a platform, and we provide this as a fully managed service from InterSystems. So it's a platform as a service offering in this space, which allows you to start delivering the outcomes from day one. And you will see shortly in a demo what I mean and how those capabilities have been put together. But essentially, if you look at it, when you're trying to build a data fabric, you're trying to connect to multiple systems. And when I say connect, either you could extract and bring the data into our platform in a staging area, or you could just connect to the external systems and just make that data available for analytics through our semantic layer or any other mechanism without having to move the data. And then on top of that, you're actually providing the business process flows and the workflows so that if something goes wrong, then the data analyst can look at the data and actually look at why this has failed. And the reason for failures might be there are validation rules. Because one of the biggest problems that we see across organizations in this space is the cost of discovering errors if within the BI tool or the reports that the business users are using is very high. It takes an awful amount of time to reverse engineer a problem that you see in your dashboards or reports and to find the origin or the source of the data which caused that problem. So it is very important that when you build your data pipelines, you put in all those validation rules, transformation rules, and reconciliation rules so that it allows you to create a trusted view of data or a data of a certain quality. Still, obviously, there would be exceptions. So, and that's the whole workflow automation built into the platform, which allows you to take these data feeds from other systems, whether they are batch, real-time, or event-based. We support all those kind of mechanisms. And then you basically persist the data into our data platform, where essentially then you start using the data either in our semantic layer, which I'll come in a moment, or you want to access that data through REST API, or you want to access that data in your Python environment for machine learning and AI, or you want to even vectorize that unstructured data for generative AI use cases. Because we all know that recently we added vector database capabilities as part of our underlying data platform. And since this service is based on that, so if there is any generative AI use case that we need to enable, that's very much possible in that space. So if you look at it, what we have tried to do is basically, again, which has always been the hallmark, is speed to value, where essentially we can provide you a service where you can start delivering the outcomes without having to spend next 6 months to 1 year first bringing all these capabilities together or a weave a fabric and then start delivering the outcomes. And if you look at the journey of the data as it goes through the TotalView platform, obviously it's the connectivity mechanism and there are different, this is just a partial list. Then you stage the data. Again, stage is an optional thing. If you already have a data source like a data warehouse or a data lake where you can just access the data and it is built for analytic workloads, you can just access it. But if you have to transform the data to a form which can be used for aggregations and could be normalized and harmonized with other data sets, then obviously you need to again bring the data into the platform. Then you need validation, reconciliation, and we also allow what we call as custom activities, which is essentially any custom processing that you want to do using our rich scripting language behind the scenes, which can be used for that purpose. And the key thing in this case is that the only skill we expect people to use this service is SQL. It's completely based on SQL. SQL is a very common language which any data analyst or a data or software developer would always be well versed with it. And essentially, as long as you know SQL, the whole idea is to make it easy for organizations to deliver these capabilities without having to worry about which programming language, what's the underlying scalability needs. We all manage that for you, basically. And once we have created the single version of data, single version of truth, then that on top of that, how can we create business representation of data? And when we mean by business representation of data, we all know that any data warehouse or a data lake, when you look at it, it's a very technical representation of data. The business doesn't want to see that. The business wants a more business representation of data where the complexity or the relationships across different data sets is already sorted. And that's what we do using our semantic layer, we built these what we call as virtual OLAP cubes, which allow you to build the business representation of data where they can actually connect their BI tool of choice, be it Tableau, Power BI, Excel, Click, or any of them. And essentially, they can just connect to the data and they don't have to worry about how the data arrived into that single version of truth. And that semantic modeling involves creating these OLAP cubes, which is almost like metadata layer for your cubes because these are virtual in nature. And that is very important because historically, when people had to create 10 different representations of data, people went about creating their data marts, writing 10 different ETL pipelines for them, and creating 10 different copies of data. The way our service works is that once you have created that single version of truth within our platform, then all the different perspectives or all the different lenses you want to see that data, you define in the virtual OLAP cube layer, and that's virtual in nature, which means it by definition is just how your cube should be. And when the query comes to the cube, it goes to the source, fetches the data, dynamically builds any aggregations that it needs to create for performance optimization. And there's machine learning built into it, where essentially on the fly, it is building those aggregations so that next time when the same queries are being asked, then the query is performing much better. And over a period of time, as more and more users are using the semantic layer, it starts getting much more optimized. And the other part is that when you are having this semantic layer, then essentially all the business users, whatever calculations that they need to put, it allows them in a very low code, drag and drop environment to build those calculations without having to build those calculations in individual BI tools, which means once you do it centrally, then no matter how people are accessing the data via an API or via Python or whether they're accessing it through a BI tool, they're always getting the same answer for the same question, rather than each individual business user trying to build their own calculations in their BI tool or in their environment. And because everybody's trying to connect through this semantic layer to all the data assets, it also enables what we call as centralized data governance. You can exactly control who gets access to what. It's not an environment where essentially if somebody needs a machine learning, if somebody needs a data set for machine learning, rather than extracting your CSV from the source system and using it for machine learning, which has no information governance built around it, here you could actually control, and people are just connecting to the single version of truth like they will connect to any database, and their role-based access control will determine what fields within that data model they have access to. Because typically in machine learning, in my data model, I might have 100 fields, but maybe for machine learning, they only need 20 fields. So why should they have access to the other data? So essentially, if you look at it, the whole idea of this semantic layer is to enable different kinds of access to the data through the semantic layer, which allows people to have a very uniform access, and whatever pipelines that you have built for the data management space, where you did the normalization and the harmonization thing, you only do it once. And how you consume that data, whether through your BI tool of choice or in your Python environment or via REST API, it's all coming through a single copy of the data without having to copy data multiple times for different types of consumers. So that's the whole idea around the semantic layer build. And that's what makes our data fabric smart. So when we say that data fabric is the idea of creating a connectivity layer across the entire organization, which basically creates a single version of truth around all the data assets. But then when we put a semantic layer on top of it, that starts becoming a smart data fabric. And if you look at it, the cases that we are trying to, or that we are working with our customers, so where do you use these capabilities? And in any shape, I would say that whichever organization we talk to it, I would say this remains a continuous challenge, if I were to say, that how do they become data driven and how they create a single version of truth. And people have invested a lot into, let's say, data warehouses, data lakes, but still they're not able to drive value out of the data. And essentially, our view on that is as simple as that. If we take care of the complexity of data management, because we've been doing it for the last 45 years, and we provide a service which is fully managed, and you start using that service for that purpose, then all you have to worry about is the outcome. We manage the entire environment. You control, you own the entire data, you build the data pipelines, but we facilitate that in by speed to value by providing you an environment where all you need to know is SQL, and you can build those data pipelines in a very intuitive UI. And then when you look at semantic load, it's again a very low code environment for building your OLAP cubes or REST access to the data. So the first and the most common use case that we come across is where people want to create a unified and a trusted and a consolidated view of their financial data for reporting and analytics. This is the number one use case, believe it or not. Everybody thinks that we should have solved this problem by now, but that still continues to remain a challenge. And how we can facilitate organizations to solve these challenges in the least possible time, that is our value proposition, because we have done all the plumbing that is needed to solve this challenge. And you can start delivering on those outcomes, basically working with us in that space. The second use case that we often come across is basically, which I've already mentioned, is basically traditionally and even today, you find in organizations to enable different kind of consumers, whether somebody's trying to use data for machine learning or somebody just needs an API access to that data because I want a 360-degree view of my customer, and I want to enable my customer so that all the relationships that customer has with me, they can access in an app on their mobile, then rather than have to have 2 or 3 different kinds of app for that purpose. Or in many cases, they can't do that because the data is not integrated in that space, which again comes to the idea that how we can access, once we do the plumbing once, then if I need a granular access to that data through REST APIs, then essentially, how can I enable that access and provide that? And the other piece that we also see in that is the timeline or the historical view for that data, especially in regulatory compliance. Because if you look at it, the way regulation works in financial services, that you are supposed to give monthly regulatory reports to the regulator. The regulator obviously doesn't come back to immediately. And obviously, over a period of time, they might come back to you and say, well, you submitted this report this month, and these numbers doesn't seem to add up. Can you show me how it is? Because we have bitemporality built into the service, which means for any data model that you're creating within this service, you can just enable the historical or the bitemporality view of that data, and it will automatically preserve the history. So if you need a timeline or a historical view of data, we can enable that very easily. The other feature we also provide is what we call as snapshotting. So you could even take the snapshot of whatever data state of data was when you submitted your regulatory report. So whatever data model you use to submit your regulatory report, you can take a complete snapshot of that so that if somebody comes back to you, you can exactly show with complete audit capabilities what was the state of that data when this report was generated. The third use case is also very common, is basically people who have invested a lot into data lakes. And the biggest challenge with data lakes was that people thought that we need all of our data structured and unstructured, and let's create a data lake where we can create a repository of all the information. But the biggest challenge is that we have created that repository, we have created that lake, but still the most difficult part is how do you use those data lakes to deliver some tangible benefits? How do you basically drive intelligence out of that data? And one of the use case we come very frequently across is basically how can we combine structured, semi-structured, or unstructured data sitting in our data lake to deliver some intelligence. So we can build those data pipelines to connect to your data lake rather than and leverage your existing investments, which you have already done in building these data lakes, rather than having to go to individual source systems, build that, connect to those data lakes, bring the data in our platform and provision the, or let's say, enable the semantic layer on top of it so people can connect any BI tool of choice or can access it in the Python environment or can access it via API. That's the other use case we see. And one of the other things that we are seeing is that the more people start using data, the other challenge that is also coming up frequently is that people who have gone down the direction of cloud-based, let's say, some of the services which basically charge you based on how many queries you are issuing, as opposed to, let's say, how much capacity you are using. So one of the key things that we have is that the way we have structured this service is that whatever is the horsepower that you're trying to use for your system. So if there are 2,000 users, but still using, let's say, a small capacity of the system, because maybe those 2,000 users are querying at different times, or maybe the query patterns are not that complex. And in any case, the semantic layer does the aggregations dynamically, which makes it much more performant, which means over a period of time, rather than going into individual source tables, you're just delivering your analytic queries out of those aggregated tables. We find that the more people start using those query-based services, the cloud bills really go up to the roof. And they have another interesting challenge that the more they democratize their data access, the more let's say, cloud bill goes up, because that's the way those query services charge you. Whereas in our case, it's pretty much based on how much horsepower or how much capacity you need for this service to serve your maximum workload. And it doesn't matter if there are 10,000 users, 20,000 users, it's the maximum capacity that you need. So in general, these are some of the use cases that I just talked about, whether it's building an enterprise reporting and analytics layer, or whether it's about building a semantic layer on top of your existing investments into data warehouses or data lakes, or whether it's the idea of bitemporality or enabling multiple access patterns on the same copy of data. This is a fully managed service available in AWS or Azure, which we provide and allow people to start solving their data challenges from day one, as opposed to spending first 6 months to 12 months in actually creating a data fabric using a lot of services in the cloud. So at this point, enough of talking. Let's have a feel of, let's say, how that TotalView software capabilities look like. I'll hand over this now to Kinshuk, who will take you through a brief demo for the TotalView capabilities.
Thanks, Saurav. That's an excellent introduction. I'm just going to start sharing my screen. Hopefully you can see the same slide again, which is what I intended it to be. So we're now going to look at InterSystems TotalView for financial services, our product offering, which is primarily a cloud-based service. And it's got a very clean, neat, tidy UI and highly intuitive. So you would start at the app menu, which explains to you what the various items on the left side are, and workflow inbox or management or entity master, all of these things are ways of interacting with the system. So what I might want to start by is showing you how you actually bring data into the TotalView service. So if I go into management and I look at data services, this is the demo system. So it's only got a subset of the different data source types that a system used by a particular enterprise may have. And it just gives you an example of the various data source types. Remember sort of saying that you can either connect or collect data, which means you can leave the data on the source system, or you can bring it on the InterSystems TotalView service. The reasoning behind that would be very much to do with the fact that is the data as it stands in a shape that you can straight away use it for analytics, and exactly what your use case is. So that might be the consideration. So once you've defined a particular service for the sake of convenience, you might want to simply import data from files if you like. You can pick it up from Excel files or just plain CSVs, etc. So I'm going to particularly use the example of the security reference files over here. And once we've defined a data source, what we are able to do is we are able to actually create a schema based on what that file structure is and allow the intelligence within the software to actually gain some meaning out of the fields. So if I look at the data catalog browser, which particularly has all of these different files already imported into it, and I might look at the security master, which is what we're using. So it's effectively parse that file and determine what the different fields in the file are, and it's created a schema, which we are able to go and edit ourselves if we find that the automated schema reader didn't do a good job. We might want to go and edit one of these fields and change it from one of these things. You can also specify primary keys, etc., which are beneficial for the purposes of indexing within the data model. So having shown you that, we then have what we call recipes. Recipes are effectively a set of steps, as you might expect, to achieve the end result. So looking at security reference data load, again, as the recipe that I'm going to use for this example here, we have various activities. And this, again, is the part where if you are bringing the data onto the InterSystems Iris TotalView platform, you're doing it because you want to do some kind of manipulation on the data. You want to check some of the fields. You want to modify things that you have, which might be the fact that you've got different fields called, or fields with different names and different systems, which are being brought together, and you need to have some kind of a universal nomenclature that you're going to apply to it. So, for instance, in this case, we are bringing the security master file. We are onto a staging area in the staging part of the activity. If I go back to the recipe again, at this stage, there is nothing much done. It's simply ingesting the data, bringing it to a staging area. And then we can add transformation activity. So transformation activity might be things like a particular field needs to have a some kind of manipulation done on it. In this case, we're using a SQL syntax to modify the security ID field within this particular data set. And then you have validation. Validation might be things like just making sure that this particular field here is within a particular, let us say, a particular range, right? So that's all we are checking over here. And it's purely for the sake of example. You might have different requirements for a particular data set that you have. And then reconciliation. Reconciliation will have a little bit more meat to it. This is where you're defining a primary source and a secondary source. And effectively, we're saying that we want to make sure that the data in the primary source and the secondary source basically agree with each other. We define various rules, what they might be. And then once that's been done, and we can actually specify within this right-handmost column whether the outcome of one of those, let's say, failed validations is fatal, in which case you would then have the ability to stop the recipe, stop the import, go and fix things that need to be fixed. Hopefully by the time you've got to this stage and you're using it for your business on a day-to-day basis, you've already sorted out these teething issues, because different data sets have quirks about them, as we all know. And if something did happen, we might then be able to go into the workflow and then see if something's gone wrong and go and check it from there. However, before we go into that, these recipes, in many of these cases, have been run manually. I'm sorry, I'm trying to go to the right side of the screen here. So it tells you that many of these recipes have been run manually. However, the security reference here is actually been scheduled to run on a daily basis. So if you go into the security reference data load, we can quickly determine that if you look at the timestamps over there, it pretty much runs once on weekdays. So it ran on the 12th, which presumably was a Friday, and then it didn't run on Saturday, Sunday, and then it ran all the rest of the weekdays. And as it says over here, don't run on holidays, etc. So it would be very specific to your use case, how you schedule these recipes to run. And once a recipe runs, it's onto the data model. And effectively, at that stage, you can go and actually work on the semantic layer. So if I went into a view of the InterSystems Adaptive Analytics offering, which gives you the ability to define the virtual cubes, virtual OLAP cubes, based on this single source of truth that you now have on the TotalView platform. And this is where you've got this single, the central trade analysis table, and from there you've got these various fields that you have used in order to start building these cubes out. And these are things that you would be able to go and design, define, and actually have this, if you like, a centrally curated semantic layer, which means that it doesn't matter which business group within your enterprise is actually accessing this cube. Everybody is singing off the same song sheet. There is no two different, let us say, definitions of what gross sales is. It is the same that every business group is actually using, every business unit. Having looked at that, you can now then surface this within a BI tool of your choice. So in this case, I've got a Tableau dashboard over here, which is taking exactly the same data, trade volume by buy sell, as it says over here, and basically giving you the different dashboard representations that are meaningful to the decision makers within your business. And all of this is made possible with the fact that the semantic layer is effectively driving that virtual data model layer between the InterSystems Iris TotalView platform and your BI tool. And it allows you to get the different views of your data that you particularly want to see. And dashboards, of course, are everyone's individual choices as to how they want them to be defined. And having said that, I'll go back to just review some of the things in the slides that Saurav has already talked about. Now, the InterSystems TotalView for Financial Services gives you the capability to take data sources, disparate data sources, bring them onto the platform, and once you've got them onto the platform, you have this universal single version of the truth within your enterprise. It is a flexible bitemporal data model, so you can go backwards and forwards in time, and any particular point in time and see what your data looked like on that particular day. You've got the ability to carry out extensive validation, reconciliation, etc. on your data. And you've got this metadata that you're generating through the schema import into the system, so you can have a very high-level view of what the data within that particular data set looks like at will. And then once you've got it there, you've got SQL access to it. You can connect via any SQL client, Java, Windows, etc. REST-based access to that particular data. InterSystems Iris is a very capable REST endpoint, or you can bring it onto your data science type of applications for any kind of exploration that you want to do with your data. So you've got Python, Java, .NET, SDKs that work. And on the right side, we're just giving you an idea of what those might look like, whether they be different applications, front office, data science, all the rest of it. So having said that, just a summary of all of the different capabilities that you've seen already. So you've got this unified data within InterSystems TotalView for Financial Services platform, which gives you complete bitemporality, the ability to go backwards and forwards in time for any business needs that you have. You've got the ability to check the data quality, satisfy yourself that it actually meets your requirement and that it actually is the version of truth that you agree with. You've got this distributed query tier, so you can query this data via any number of different mechanisms and build that universal semantic layer, which we looked at earlier, so that you can surface this within your BI tool of choice. And last but not least, you've got the metadata management, which means that you've got a ready view of what your data set looks like. And if that changes over time, you can go backwards and forwards and see what the data looked like at a particular point in time. And having said all of that, I'm going to hand back to Saurav to wrap up the...
Yep.
Oh, thank you.
This pretty much slide looks at all the capabilities that TotalView has. The key thing is that it's a fully managed service offering, which means that InterSystems provide this in your cloud of choice, AWS or Azure currently. And essentially, we would provision the entire environment and you will be supported to typically InterSystems support like you have been used to. And essentially, you start building your data pipelines and create your single version of truth and become a data-driven organization. That's the expectation with this offering. And I think so it takes away, if I were to say, many challenges around data management, complexity of data management, I would say managing platforms. So rather than you have to manage all the services that you might need for a data fabric, we are providing this as a single unified service behind the scenes. Obviously, we are managing Iris. It's based on Iris. And the key value proposition here is that to solve these challenges, you're providing what I would say is a unified service, which gives you speed to value. Any questions at this stage, please? There's nothing in the chat window, but I'll open the forum to all the participants. If anybody has any questions, I'm more than happy to take those questions. We do have 10 minutes left or 9 minutes left. So if there are any questions, please ask.
You can always email us questions afterwards if something comes to mind.
Yeah, Kinshuk, if you go to, in the slide pack, what you will see is that if you advance the slide back,
of course,
you will see that our next Tech Talk session is basically our health share patient index. Again, most of the people on this forum are not in healthcare. But in case anybody is here who's is in healthcare, then just to let people know that our next tech talk will be on health share patient index. And the slide deck will include our contact details for myself, Kinshuk. And if there are any questions that you want to be answered after the session, then please feel free to contact us. You would get the slide pack and the recording would be available for you to look at it again as well.
There is one more slide after this. Yes, of course.
Yeah. So